Good evening, students. In the previous lecture, we have discussed about Bohr's atomic model and its postulates. All the formulae we have discussed. Now, in today's class, let us solve some numericals. As a revision, I have written the formulae. The first one, Rn, we know the radius of any shell is calculated by 0.529 into n square by z. What is n here? N is nothing but number of shell and z is atomic number. So here in the angstrom unit, which is nothing but 10 to the power of minus 10 meters. So first one we have to apply. Second one, angular momentum. MVR is integral multiple of h by 2 pi, nothing but nh by 2 pi. Here what is m? Mass of electron. What is v? Velocity of electron. And what is r? The radius. So any one term you can calculate using this formula, and n stands for the number of shell and h stands for Planck's constant. Now if you want to know how many number of revolution it makes, that means at the center you have nucleus and in the shell, let us take, an electron is revolving. So how many number of revolutions it makes per second can be calculated by its velocity v by 2 pi into radius. Now the fourth formula, what is the energy associated with each shell? So if you want to calculate per atom, this is the formula, minus 2.18 into 10 power 18 into z square by n square. So here why negative sign is there, we have discussed in the previous class. That means if you are moving away from nucleus at infinity, the value is 0. And if you move towards this, attraction between positive charge and negative charge will be there, hence what happens, energy decreases. That means from 0 it gets decreased, so the value will be in minus. So that is why we have written minus here. Hope you are able to understand. Now observe the questions here. Take some time to solve these questions. After that I will give you the solution. So hope you are able to see that. Try to solve each question in 1 minute. First one, calculate radius of Bohr's third orbit in Li plus 2Ir. So question number 1, what is given? Third orbit means n is equal to 3 and Li 2 plus is given. So therefore, what is the atomic number of lithium? Atomic number of lithium is 3. So Z also 3, N is also 3. Next, what they are asking? They are asking to calculate the radius of third orbit, hence we can write R3. The formula is there, 0.529 into n square by z angstrom unit. On substituting we get 0.529 into n is 3, so 3 square by atomic number is also 3. So you can cancel this 3 now into 3, so 9 3s 27, 3 to 6, 7, 8 and 5 3s 15. So we have 1.587 angstrom unit. So the radius we got. So hope you are able to understand this. Now let us move to the second question. You try to solve this. Velocity of an electron, they are asking in centimeter per second. CGS unit in the third orbit of H, that means n is 3 and z is 1. And also you have to calculate number of revolutions. So formula is v by 2 pi r. So try to solve this. Hope you have solved the second question. Now let me write the solution of this. What is mentioned here? Velocity we need to calculate, and n value is 3 and z is 1. And also you need to calculate number of revolutions. First let us see the formula. MVR is equal to nh by 2 pi. We need velocity. Therefore send it to other side. V is equal to nh by 2 pi into mr will come here and we will get this formula for velocity. One more important thing, you know n, Planck's constant h, and mass also you know, but the radius is not known. How to calculate the radius? Formula you know, Rn is 0.529 into n square by z angstrom unit. But we need in centimeter here, because they are asking velocity in centimeter per second, we have to take it in centimeter. Now find out the value here. 0.529 into what is the value of n3? So 3 square is 9 by atomic number is 1, so as such you can write into 10 to the power of minus 10 meters. Let me take this. 529 into 9 we will calculate into 10 power minus 10 into 10 square centimeter. Why I wrote 10 square? Because 1 meter is nothing but 10 square, 100 centimeter. Now what is the answer here? So 9 into 9, 81, 9 to the 18, 26, 9 5 is 45 and 47. We get the value of Rn, nothing but it is 3. R3 is equal to 4.761 into 10 to the power of minus 8 centimeter. Now we got R value. Let us see. V is equal to N is 3 into H 6.626 into 10 to the power of minus 27 erg into second. See here we are not taking joule because we have to write in the CGS system. So minus 27 divided by 2 into pi value 3.14 into what is the mass here again 9.1 into 10 to the power of minus 28 grams. Once again we have taken in gram, not in kg. And radius is 4.761 into 10 to the power of minus 8 centimeter. Hope you are able to understand. Now for your convenience I have already calculated nothing but 0.729 into 10 to the power of 8 centimeter per second. You can calculate it and find out, and I already did that. So velocity is 0.729 into 10 to the power of 8 centimeter per second. So first we got velocity. Now what is the second portion of the question? Calculate the number of revolution. Now let us take the formula. Number of revolution is V by 2 pi r. Now you know what is the value of V. 0.729 into 10 to the power of 8 divided by 2 into pi value 3.14 into what is the radius? 4.761 into 10 to the power of minus 8. So finally, what is the number of revolutions we got? I calculated 2.4 into 10 to the power of 14 revolutions per second. So to save time I have written the answer. Now I hope you have understood this. First formula, MVR is angular momentum NH by 2 pi. So in this we need to calculate V. So send this to other side. And we are not having radius. So calculate radius using the formula and you got the radius. Next on substitution you got velocity. Now in the second question, to calculate revolutions per second, the formula is V by 2 pi r. You know what is V, you know what is radius. On substitution you will get 2.4 into 10 to the power of 14 revolutions per second. Hope you are able to understand this. If the values may change, you can easily get the answer. Third one, calculate energy associated with first orbit of He plus, and you also have to calculate radius. So use this formula and try to do that in less than 1 minute. Fine, hope you have completed this. My target is to give you more and more number of questions. So we also will solve ISC questions and then JW and NEET questions also. Now in the question number 3 you have find energy associated with first orbit. That means N is equal to 1. So helium is given. Atomic number of helium is 2. And they are asking the radius as well as energy. Now let us see the formula. The energy is given as minus 2.18 into 10 to the power of 18 into Z square by N square joule per atom, or ion also. Here we are taking ion. So in this condition, minus 2.18 into 10 to the power of 18 into z is 2, so 2 square is 4 divided by what is n, 1 square is 1. Fine. Now into 4, 8 4 is 32, 4 1 is 4, 7 and 4 2 is 8. So we get the energy which is present in first orbit E1 is equal to 8.72 into 10 to the power of 18 joule. Hope you got the same answer. Now second one, they are asking radius. Formula Rn is 0.529 into n square by z angstrom unit. Let me substitute this 0.529 into what is n here, 1 square is 1 by atomic number is 2 divided by 2, what you get? So this is 0.264 and 5. 0.2645 angstrom unit. Hope you are able to understand this. Very simple. First, calculate energy by using En is minus 2.18 in 10 power 18 z square by n square. Second one, radius is 0.529 into n square by z. Now let us move to question number 4 and 5. Now question number 4. Read it for once and you can try to solve it in less than 1 minute. I have given the formula here to recall. Wave number is nothing but reciprocal of wavelength 1 by lambda. R is Rydberg constant 109,679 per centimeter. You know, 1 by n1 square minus 1 by n2 square, where n2 is always greater than n1. Ionization energy formula is minus energy of the first orbit. You know what is ionization energy? The energy which is required to remove electron from outermost orbit. Now E1. What is the formula to calculate the first orbit? That is E1 energy is minus 13.6 into z square electron volt. So apply these formulae and try to solve these questions. Now question number 4, I'll give the solution. Wave number is equal to 1 by lambda. They are asking to calculate lambda value. First let us see wave number is equal to r into 1 by n1 square minus n2 square. Here always the value of n2 is greater. They have mentioned from n is equal to 7 to n is equal to 4. So hence we can easily identify n2 is 7, n1 is 4. And r value is 109,679. So on substituting this, we get 1 by 4 square, nothing but 16, minus 1 by 7 square, 49. On taking LCM, 16 into 49. So here you know that process, you know, 1 by 16 into 49. So 16 gets cancelled and you get 49. Minus second one also, you know, 1 by 49 into 16 into 49. 49 gets cancelled and here you will get 16. So what is 49 minus 16 here? 9 minus 6, 3. 4 minus 1, 3, 33. So therefore we get 1 by lambda is equal to 109,679 into 33 by 16 into 49. Suppose you want to find lambda, what you will do? Send this to other side or you can calculate here itself. Now you can calculate lambda directly. Therefore lambda is equal to, so lambda will come here, the whole thing will come to the other side, 16 into 49. So the denominator will come here to the numerator and the numerator will come to the denominator. Hence 109,679 into 33. Now I have calculated earlier for convenience. So what is the answer here? The answer is 21661 angstrom unit. Nothing but 10 to the power of minus 10 meters. Hope you are able to understand. We got the formula. that is wave number is 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Apply this and you will get the answer. Sometime they will ask wave number. So wave number, we can stop up to this. Now try to solve the second one using ionization energy formula, nothing but minus energy of first orbit. First calculate energy of first orbit. So I think you have understood the formula and you have calculated. If not, you just see the solution. First let us see for He plus. Formula you know, that is if you are calculating E1, nothing but minus 13.6 into Z square electron volt. Here what is atomic number of helium? Z is 2. On substituting we get minus 13.6 into 2 square is 4. 6 4 is 24, 4 3 is 12. So the answer is 54.4 electron volt, that is minus. So E1 value you got. Now what is ionization energy? Minus of E1. What is E1? Minus 54.4, minus into minus plus. Therefore the ionization energy of He plus will be 54.4 electron volt. Hope you are able to understand. Any other question will be there, you please follow the same method. Now for Li2 plus they have given. If you are taking energy of first orbit minus 13.6 into Z square eV, atomic number of lithium is 3, minus 13.6 into 9 electron volt. So it's 122.4 eV minus. Ionization energy of Li2 plus is nothing but minus energy of first orbit, nothing but minus of minus 122.4. So finally you can say that the ionization energy here is 122.4 electron volt. By using this method we can calculate ionization energy of any single electronic species. Hope you have understood this. Now let us move to JW NEET questions. Now coming to the JW NEET questions. The first one, what is the equation corresponding to wave number of spectral line in bracket series? They have given 4 options. Second one is electron in the 5th orbit is excited and it's returning to the ground state. Find the number of lines. So for this you know the formula. First one, the wave number is equal to 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square, where n2 is always greater than 1. That means this is from and this is to. It is first formula. Second one, in any spectrum, how to calculate number of lines? See, I am not talking about total number, it is only in a particular series. For example, here they are asking Lyman series. The formula is n2 minus n1. So these are the 2 formula you have to apply. I have explained you. Now you can try it and solve it in less than 1 minute. If not, then you can check the solution. First one, wave number is equal to 1 by lambda is r into 1 by n1 square minus 1 by n2 square. From where it is coming in bracket series. Let us see what are the series here. Already we know Lyman, Bohr, Passion, bracket, Fund and Humphrey series. We have discussed this in the previous lecture in the hydrogen spectrum. What is Lyman series? From any, that is nothing but energy level, any energy level, it is coming to 1. From any level it is coming to, that is 2, 3, 4, 5 and so on. Same way, from any level, that is 3, 4, 5, it comes to 2, it is called Bohr. Passion, from 4, 5, 6 and so on, this is coming down to the 3rd energy level. Now we are in this bracket. From 5th, 6th, 7th, etc. If the electron gets de-excited to 4th energy level, that is called bracket series. Now we have to find this. Now let me write what is the value here. this is N2, this is N1. Substitute that. R into 1 by N1, you know, 4 square minus 1 by N2 is 5 square. So this is your wave number. So can you see this option? Yes. So B is the answer. Hope you are able to understand. Now try to solve this in less than 1 minute. I think you have completed. If not, let me solve this. So electron in the 5th orbit, and that too in the Lyman series, is returning to the ground state. Now if you take Lyman series, so N1 is 1 and N2, it can be from 2, 3, 4, 5 and so on. Now they said that N2 is 5, N1 is 1. Hence, number of lines in the particular series, that means here we are having Lyman series, is N2 minus N1, 5 minus 1. Hence you will get how many lines? 4 lines. So answer is this. Suppose they are asking what are the total number of spectral lines. Then you know the formula, that is delta n into delta n plus 1 by 2. Hope you are able to understand. This is not the question, but if they give what are the total number of spectral lines, means from 5 to 1 total you need to calculate. So you can use this formula. Now let us move to the question number 3. Now let us see question number 3, 4, 5. First you observe the questions. Try to solve in less than 1 minute. I have given the formula. So if you recall angular momentum MVR, NH by 2 pi. Energy in initial can be minus 13.6 by n square eV, which says that the energy is inversely proportional to n square. Velocity in initial is 2.188 into 10 power 8 by n in centimeter per second. Apply these formula and try to solve. Now let me write the solutions. That is question number 3. If you take angular momentum MVR is equal to NH by 2 pi. So they have mentioned 5th orbit. So n is equal to 5. Therefore substitute this and get it as MVR is equal to 5h by 2 pi. So you will get the answer B, 5h by 2 pi. Now check the question number 4. Each hydrogen is excited by giving 10.2. That means what do they mean? They mean that delta E is 10.2. Maximum number of spectral lines. For that you have to calculate what is N1 and what is N2. Now let us apply the second formula. You know that En or E1 is equal to minus 13.6 by 1 square eV. Therefore we know that E1 is minus 13.6 eV. Now same way you calculate E2. So minus 13.6 by what is n here? 2. Hence it is nothing but 4. So what you get? 4 3s 12 and 16. 3.4 eV minus 3.4 eV. If you take delta value, it is nothing but E2 minus E1. So we can say 13.6 minus 3.4. We can easily understand that it is 10.2 eV what you got here. Hence what is the value here? We can say that the transition happens between second orbit as well as first orbit. I can write like this: N2 is equal to 2 and N1 is equal to 1. Applying this, you have to find the number of spectral lines. I think you have understood this. Let me erase and write down number of spectral lines. N2 is 2 and N1 is 1. From the first part we got. Now number of spectral lines is delta n into delta n plus 1 by 2. What is delta n? N2 minus N1, nothing but 2 minus 1, therefore delta n is 1. On substituting you get 1 into 1 plus 1 by 2, nothing but 1 into 2, 2 by 2 Answer is 1. Therefore, we get only one spectral line here. Hope you are able to understand this. Now moving to the next question, that is question number 5. First find v1 and then you know the velocity of light. So if you write the velocity of light 3 into 10 to the power of 10 centimeter per second. And now what is Vn? And we have mentioned that first orbit, therefore n is 1. So we can say that n is equal to 1. Let us write V1. So what is V1? 2.188 into 10 to the power of 8 divided by 1 centimeter per second. Now they are asking what is the velocity in the first orbit of hydrogen compared to the velocity of light. So let us see, this is velocity of hydrogen in first orbit, Vh by velocity of light, nothing but 2.188 into 10 to the power of 8 by 3 into 10 to the power of 10. Now approximately we can take it and cancel this. So what you get? So we will get it as 1 by 10 square, nothing but 1 by 100. So here answer is B. So by applying the formula for velocity, you will get the answer. So using this we can solve the given questions. Now today we have discussed 5 objective questions as well as 5 subjective questions. In the next lecture we can continue with the remaining objective questions. Hope you have understood this. Thank you so much.